Okay, going on now to topic 2 of chapter 9, addition, rules of probability, and odds. Again, this is some hands-on practice. Find the number of outcomes in the complement of the given event. So again, never hurts for a little review. So we're going to make a little Venn diagram. This is the universe. And what are we looking at? Strawberry plants, raspberry that are ready for picking. All right, so this is going to be 182. Now the total universe, I'll put it up here, is 340. And what we are wondering about is the complement of this event. Now, if this is set R, what is the complement of this and how do we find it? Well, if you said we're going to take 340, subtract 182 from it, this will give us our complement, and this would be those that are not ready for picking, and this comes out to be 158. So we can think of this as, if this is R, then this would be R complement. So it would be everything in the universe that's not here. This is the total universe. These are the ones that are ready for picking. So out here would be the complement of R. Okay, you have some notes and hopefully understand what's going on. All right, for number 2, let's see if we can find the complement of this event. Take a moment, pause, and let's see if you can describe it. Now they're asking for describe as opposed to a number. So if 72 of the subscribers for a fitness magazine are over 22, the complement of it would be subscribers under the age of 22. And again, the wording could be slightly different, but and if we were going to ask, what percent would that be? Well, 72 from 100 would leave us with 28%. But they're not asking us for that. They're asking what would the complement be described as. Okay. Going on to this next one, we're going to see if these events are mutually exclusive. All right, take a moment. Well, you're going to have math majors and you're going to have Spanish major. So are these events mutually exclusive? And assuming that a student can only have one major. And the answer is yes. Now, if they could have more than one majors, then they wouldn't be mutually exclusive because some could take both. But that would be a funny combination. And I see we may have a number extra there or short one. Not a problem. Just help spread things out. All right. Number 3. Again, based on your flipped classroom viewing, what would the answer to this be? Now, that would be, in probability, would be 99 out of 100. But what would be the odds? and that would be 99 to 1. Now remember, in odds, the sum of the odds adds up to your sample space. All right, let's do number 4. Find the probability of choosing a letter, and this is key, you have to read it correctly, other than A from a bag containing 18 letters that are found here. Express your answer as a fraction in lowest terms, or a decimal rounded to the nearest millionth again. So we know our sample space is going to be 18. So let's see what you get. Now, if you count the number of A's, there's 1, 2, 3, 4, 5. So in a sense, it would be 18 minus 5. These are the A's. So to get other than A's would be its complement in a sense, 13 out of 18. And the decimal fraction for that is 0.7222222. Rounding it to the nearest millionth, we need 6 places. 1, 2, 3, 4, 5, 6. Our 7th place is a 2, so we just drop it, and this would be our answer. Okay, if you're not sure of something, be sure you're asking. Now, this one's a little tricky, so we'll read it together. You have 15 marbles, so our sample space is 15. Now, there are 7 marbles with red on it, so 7 red. 4 with blue, 4 with blue. 8 with green, 8 with green. And here's sort of the interesting part. There are 4 with red and green on them. So pause and see what you can come up with, and then we'll go over it. So as we analyze this, they're asking, what is the probability that a randomly chosen marble has either green or red on it? Well, here's our reds. Now there's our greens. But these now include red and greens that could be on these as well. So you would have to subtract this overlapping so they're not counted twice. So this is 15 minus 4 will give us 11 out of 15. And they don't ask for a decimal, so this is satisfactory for an answer. So the tricky part, now keep in mind, if you just added all these together, you're going to get 19. Well, there's only 15 marbles. That's the challenge of this. So again, some of these reds could be containing green, and some of these greens could be containing red. So if we add these two together, we have to subtract those that would be, in a sense, counted twice. All right, let's go on. In example 6, we have a table, and it's asking us to find the probability that a randomly chosen member of the Student Council Board is a senior or someone who lives off campus housing. Express your fraction in lowest terms or rounded to the nearest millionth. Okay, so pause. I'll give you a hint. You have to find out what your total is. And I did that for you in a sense. That's 19. Adding all these up. So what will you put up on top here? Remember, you can't count things twice. Okay, so seniors. We have 4 and 2. So that would be 4 plus 2. And then those that live off campus. So we have 3, 6, 10. And then you're saying, wait a minute. We already counted the seniors by being seniors, even though they live off campus. So we can't count these twice. So we'll just subtract 2. Now, if you had done it the other way, count all of these and then add the 4, that would be another way. But if you're counting all the seniors, all those that live off campus, you have to subtract the 2 because it's used twice. So this gives you then 14 out of 19. Again, not bad if you see what's going on. And the decimal fraction for it is 0.736842. Goes on. We want 6 places. 1, 2, 3, 4, 5, 6. A millionth. And then this is the one, so we just drop it here. Okay. Now again, the chart is there. And our total, our sample space here is 196. Now the following table, both faculty, recent, campus. Find the probability that a randomly selected person is either in favor or opposed to the restructuring of this honors program. Okay, so here it doesn't make any difference whether it's faculty or student. We want those in favor, which we see here is 47, and those opposed, 89, and we're not including the neutrals. So it will be the sum of these two, which is 136 out of 196. And they want it in lowest terms. So we can take a 4 out of each one here that I worked on already. And I got 34 out of 49. And to the nearest millionth is 0.693. I'll do that here in a minute. They're a little easier to read. So we need 6 places. 1, 2, 3, 4, 5, 6. We go to our 7th place. It's 5, so we're going to drop it, but make this 7 and 8. Now, we could have done this by using the complement, subtracting 60 from this, and then we still get the same result. So this is sort of straightforward. There may be more than one way to do it, but this is a good way that I'm illustrating. Now, dealing with deck of cards, and again, in the Flip Classroom video, we go over that in some detail. We want to know if these events, choosing a 10 or a black card out of a standard deck of cards, whether or not it's a mutually exclusive event. Well, what do you think? They are not mutually exclusive because there are some 10s that are black cards. All right, one more to go. And this one's sort of a challenge. So we have a container with balls that are numbered 1 through 20. So this is what you're going to have to do on your paper. So we'll take a moment. Now, what is the probability that you will randomly select from this a number on the ball which is divisible by 6? So let's select those. That'll be a 6, a 12, and an 18. These are numbers divisible by 6. Or we'll have an value 11 through 16. So I'll do these in blue. We have 11, 12, 13, 14, 15, 16. Okay. So how many then, because we know our sample field is going to be 20, how many meet our criteria? And again, we can't count things twice. Well, 6, 12, and 18 are 3. And then we have 1, 2, 3, 4, 5, 6. But this one's counted twice, so we have to subtract 1. And then this will be 8 then out of 20. Take a 4 out of each. This is 2 out of 5. Now, again, some people, if they're good conceptually, they wouldn't have to do all of this. But it's good to see it laid out. And then here you realize you could have counted this only once. 1, 2, 3, 4, 5, 6, 7. We do it again. 1, 2, 3, 4, 5, 6, 7, 8. Yes, that would give you the 8 out of 20 because you're not counting this one twice. But if you did it separately, you had 3 plus these, that would be 6. Plus 3 is 9, but minus 1, 8. A number of ways to figure it out. And there's your answer. Again, if you have a question,